All right, welcome everybody. So as our introduction was, my name is Aubrey Chipman. This is my teammate Roberto Perez Alcalea. And today we're talking to you about how improving the testing experience goes beyond quality, a developer productivity point of view. So let's cover what we're going to talk about first of all. So we're going to talk about why are we focusing on improving the testing experience. We want to talk about what it looks like in the day of the life of a developer at Netflix. What does it look like in the Netflix JVM build landscape? What are some common problems that we see? How do we go about improving these? Things we learned along the way, and finally some time for questions and answers. So let's get going with why are we focusing on improving the testing experience? So as you have heard today and probably also are familiar with, we want to make sure that we're feeling good about what we're working on. We want to be motivated. We want to have a nice state in our mind that we're getting things done, that we're being productive. And we call this a flow state. And it takes a while to get into it. Some people say it can take like 15 or 30 minutes. And you want to be able to have your thought processes just go along in this. So the other case is that if you're having interruptions, you're having mental context switching, this can bring you out of the flow state, unfortunately. So this might be things like responding to messages, triaging a broken build for things that is not what you were working on, or investigating how to use a new tool. So how can we go about thinking more about this? Over at Netflix, we talk a lot about the developer inner loop and outer loop. And these are things that are broken down into items that you're doing fairly infrequently, once a week, little less often than that as the outer loop, versus the inner loop. These are things that you're going to be doing daily, hourly, even more often. And specifically, we're talking to you today about this developer inner loop and the testing experience. So ideally, you're going to be writing some code, running some tests, writing some code, running some tests, and just doing this very, very often. So testing is crucial in the inner loop, and a suboptimal experience here leads to all sorts of context switching and losing this crucial flow state. Brings us to Roberto.
Thank you. Well, good morning, everyone. So before we jump into the problems that we see here at Netflix, I'd like to talk a bit on what is the life in a developer when they live in a low productive environment. So imagine that this was me yesterday, after finishing my slides for today, of course. Everything is green, right? I'm working on this particular simple project. It's a Java library. I was able to deploy it. We are using Spinnaker, which is a Netflix continuous delivery platform. I went home. Everything was fine, right? So much happiness. And then Wednesday morning, so good morning, sunshine. And the developer noticed a lot of things. Everything is red. Jenkins is red. They start looking into what happened. They put the latest changes. They realize that they cannot even compile the code. And after some time, maybe a few hours, this developer in particular managed to fix the build. But at the very end, the developer was thinking on something else when he or she started the day. He was probably looking into how to optimize something within the project scope, but then he got into this state. So then, after some time, this person managed to fix a problem, pushes the thing to CI, and a test fails. A test fails that is not related to the changes she was working on. What happens there? Well, after another couple hours, she realizes that probably this is a flaky test. Or is it a broken code? Who knows, right? But in reality, it's not related to what she was working on from the very beginning. So the developer is very frustrated at this point. They went to probably the whole day, and then they managed to fix that particular issue and get the build into green state. But guess what? Getting that build green took minutes or hours because it's going as slow as possible. So at the end, the developer feel like, yeah, I'm done, and didn't achieve much. It's frustrated and unmotivated, and probably really thinking about how the day is going to look like the day after. So before we continue looking into these problems, I would like to share a little bit more about the JVM build landscape, just to get some context and the perspectives on how we are approaching this. So over a period of 28 days or a month, Netflix has close to 850,000 builds that get executed every single day between build and CI, between local and CI, sorry. This means that there are many, many test cases, 14 million test cases that get executed every single month. So as you can imagine, when these things are really slow, the developer feedback is super slow and is not so good. People get frustrated, and really, really we want them to run locally as much as possible. Get that inner loop going, get faster feedback as soon as possible, making sure that they are in that flow state. So we're going to focus on testing, but really at the project level. One thing that we are not going to touch today is anything related to verification after you deploy your services. So we won't talk about canaries or any other strategy that will allow you to know if things are going well or not.
Okay, this brings us to common problems that can exist in a software testing experience. What might some of these be? Well, let's say testing has become difficult for some reason. Maybe there's hard to write tests with the provided tools right there. Maybe this code base was made at a time where they didn't focus on testing things first, so there's not good seams to write tests there in the first place. Maybe there's a lack of actionable feedback from your outputs. There's error code 1, or something went wrong, unknown error. This is not the most useful thing to debug. It could also be that the test suites didn't evolve at the same time as the production code. There could also be lack of documentation. Here's how you can go about testing this. Go read this other code base. So there could be other issues as well, like there are tests, but they are flaky. So flaky tests are the ones which fail to produce the same outcome with each individual run. Some reasons for this might be things like you're looking at the wrong thread, there's asynchronous waits, there's concurrency and parallelism that you didn't take into account. Maybe you expected to have this test start with a blank database, but instead there's data already there. So there was a test order dependency problem. Maybe you have a poorly modeled test. You're depending on a clock, you're depending on a time zone, or this database in a certain state, and it's not always going to be like that. Another aspect of this is that when you have these flaky tests, this can and will frustrate developers, as Roberto was just talking about. So in order to ship a change, people might, 1, delete the test because it's not giving that confidence and that feedback that they need. They might ignore the test and then never revisit it. Or they could alternatively identify this flaky test and then fix it right there in the moment. But whatever the case it is, if you're having flaky tests, you're going to have one of these particular feelings up here, and people might start losing confidence in this test suite. Another issue might be that there are tests, but they're slow. So there might be test resources that are shared. There could be test setup or teardown times where you need to inject a lot of things into the test itself. Maybe you don't need to test all of those items, inject all of those items. Maybe there are hardware constraints where you're not able to parallelize your tests as much as you want to. Another thing might be that there's tests, but they are inconsistent. So typically we run our local builds on a Mac machine and run our CI builds on Linux machines. So there could be inconsistencies there, things with memory, hardware requirements, things with Docker setup. There might also be network and security access issues that are going on. So are these issues causing problems in my organization? Most likely yes, because they have been over at ours. And because of this, developers can get frustrated, and it's possible to fall into these following traps. So we want to talk about how we should not be doing these items, where people might want to avoid writing tests. They might ignore or remove the tests entirely. They might avoid running their tests locally, just push things up to CI and say, well, everything works in CI, so I'll just push it up there all the time. I don't want to run this locally on my own machine. And instead, we want for people to run things locally and get that feedback quickly. So this is what we're talking about over here with this developer inner loop, where we want people to stay in this flow state, get that feedback nice and quick, and be able to go through making their changes, running their tests. Here's a quote from one of our teammates, Danny Thomas, that we like to bring out because he said it so eloquently. He said, "It is staggering how tolerant engineers are of toil and frustration and friction." So over at Netflix, we're not immune to this, unfortunately, and we have invested upon it.
So let's talk about how we can improve this testing experience for engineers. And what we have done on Netflix is not specific to the company, really. There are things that we can apply on every single project across the industry. And this is why we are here today, trying to share a little bit of what we're doing, and that it could be replicated regardless of the scale, as we call it. Like it could be 1 project, 2 projects, thousands of projects. So let's talk about faster test style. One of the things that Aubrey mentioned before is how tests can be slow. And one of the things that we notice is people tend to wait a lot of time just to get their test set up ready. They go and say, this thing is taking minutes. I don't know why. So let's take a look on a real world example. So this is a project setup that is quite common for Java engineers at Netflix. They use a Spring Boot. They are using CoverGB. They are testing that database and integration tests using test containers. And to manage the evolution of that database, they use Flyway. And maybe even at this point, they're using Juke to do a static SQL statements in Java. So these are really, really great tools. And you use them, they are open source, they are well supported in the community. But this is what was happening with this particular project. The engineers, it is important to say that we productivity teams at Netflix, we are there not only to create platform tooling, but also to enable people to do their job better. So they come to us and say, you know what, this is very slow. What can I do about it? So we start consulting with them. And what we notice is, if you look at this particular slide, executing a test method takes less than 2 seconds, which is fast, slow. Everyone has their own perspective. But what we can all agree on is that 2 minutes for setting up that test is really, really hard. So we spent time looking at the bottlenecks with these folks, and we found really interesting things. One was we were taking up to a minute just applying Flyway migrations, basically taking those SQL statements every single time that they were running a test and applying those on the fly to get the database into a state that they can run integration tests against. And the other one was starting a container, like Docker container on an M1 was taking 13 seconds just to get a simple CoreLaunchDB throwaway database. If you look at this is more than a minute just spent on test setup. And also people were doing this over and over again on every single integration test class. So the tools were not the problem really. Like these tools, as I said, they are super good, but it's how you use them. So why was so slow? Well, people are writing tons of migration files, multiple SQL statements. You are running each one of these one at a time. You are using Docker. If you are using Mac computers, if you get the latest M1 or M2, you're using Docker in Mac. And most likely, if you have a database that doesn't have a Docker image that is compliant to that particular processor type, well, you will be paying the tax of virtualization. So what we found is that just by trying to run CoreLaunchDB from AMD 64 to ARM 64, we were paying 10 seconds just for the startup time. And that was in nature, that was expected. That's the trade-off that you're paying for doing this. But this is not acceptable for the testing experience, in our opinion. And the other thing is, you spin up multiple containers. There is so much compute that you might have locally on CI, and you don't want to exhaust it just because you want to run hundreds of databases for your integration test. So you should be reusing them. So we continue consulting to this team, and we fixed those. We reduced the build time for more than 50%. There's still low-hanging fruit that we can take from there. But you can see that now the setup is less than 50 seconds, and running the test in particular takes less than a second. So what did we change? Simple things. Do baseline of the migration files, just one single file that gets calculated every single time there is a change. We started using single patterns for containers, just one container at a time, and we leverage Test Containers Cloud. Test Containers Cloud allows us to run containers on a remote cloud environment without having to deal with the particularities of Docker in Mac at that point. So we saw that that particular container started taking the promise less than a second startup. What other things are we doing here? Well, our teams are looking into test slicing, reducing the application context and even the data that you need to validate your software. Making sure that context initialization is fast enough. And then we also found that people were complaining not only about the test, but the startup time of our frameworks overall. So really we started investing on better modularization, trimming dependencies. For people working in the Java space, well, you know, the less dependencies we have in the class path, cloud is going to be faster, everything is going to be better, right? So spending on this really help us to get into a better state. And these are opportunities that we found that we can standardize tools across teams. So now we are working with teams to making sure that this is an end-to-end experience for every single engineer at Netflix. So we can replicate this pattern for most of our repositories. So one of the contexts that we forgot to mention is that Netflix is not a monorepo, it's a multi-repo. So today we have more than 3,500 repositories with JVM code. So it is really difficult to make a change once and apply to everyone. What we are working in automation or abstracting these tools into plugins for people to use them.
All right, that brings us over to Flaky test detection and remediation. So this one item that we're going to talk about right here can be applied to one project, just as Roberto was talking about, as a one project kind of solution, but it could also be applied to a bunch of projects all at once. So first of all, what is a flaky test? Well, whenever a test fails, if you rerun it and then rerun it and rerun it and it's still failing and eventually it succeeds, well, you've got yourself there a flaky test. So why is this really important to think about? Here's an image of the testing pyramid, which y'all are probably very familiar with. And the thing I want to call out over here is that unit tests are things that are going to be nice and simple. They're over here at the bottom of the pyramid. As you go higher up, you have things like smoke tests and manual tests. There's a lot more complexity inside of here. So as you have flaky tests, these are going to affect those higher level tests much more often because they take longer to run, they take longer to debug. There's just a lot more complexity going on in there. So when we have these flaky tests, it's good to know that we have them, but how do we go about seeing them? How do we see them in a great way? We can know how much they're actually affecting our organization. For this visualization, we use Gradle Test Retry Gradle plugin to 1, retry these tests and then find out if they are flaky, and then 2, to catch and then visualize this test flakiness. So here's an example of all of our data from the last month or so, August 8th through September 4th, as we were pulling this. This is from our actual instance of Gradle Enterprise flaky test detection. And we can see that we were running about 500,000 builds that were executing tests. Of these, 1% of them have flaky tests. So that's not good. That's a lot of time spent just rerunning things and having people that might need to investigate some stuff. So we can drill down into this and look at flaky detection by class as well. And this really helps us out. So for example, this one class, a repeat offender, we might say, on 42% or 42 of the builds that went through, they succeeded on the first time, all the tests in this class. However, there were 296 builds where the tests that were inside of here, they failed, and then they might have failed again, and then eventually passed. So there was that time spent in the retry. And you can see that even retrying it a few times was not necessarily enough to make sure that the build was going to go through. There were times where this failed, and then the build overall failed. So what does this really mean? The next impactful thing I want to talk about is that it's not just the unit test that runs in 1 second that's failing. In this case, this test took 3.5 minutes every time it was being retried. So those 296 times we're retrying this test took over 17 hours of build time. And that really adds up. This is just one class in one project. And when we're talking about the Netflix JVM ecosystem, this is really impactful. However, just having this data is not the same as solving the problem. So there's an additional part inside of here as well. What we want to do about it is we want to be able to surface this information to our engineers in a friendly way so that they can see that there is some tech debt here. It would be great if you want to address this. It helps your team, it helps our infrastructure, it helps a lot of troubleshooting from all the various people who might be involved. So that is part of a culture change. Another area where this could happen is just working on quarantining these tests. Are they giving you the confidence that you really want out of a test? If it's flaky, if it requires this inconsistent kind of troubleshooting, you have to weigh these options. And our goal is that someday we will have all of our builds without any flaky tests. Which brings us to...
Well, thank you. So far we have been talking about things that you can do at the project level regardless of how many projects you have, how many repositories. And this also applies this way, but it really works outside of the test execution or the test configuration level. So let's talk about predictive test selection. It's very clear that people have been talking about how can I speed up testing, not only from Gradle folks, there are many other companies looking into this. And this is because we have found that 88% of our engineers at Netflix in the JVM space really wait for the build to finish because of test. So we started looking into predictive test selection, and basically it's just an ML model that, in the context of Gradle, it takes all the inputs from the test task and all the things about code changes. This particular thing was popularized by Meta years ago. Meta has been using this approach, ML-based, for deciding which test to run. But in a nutshell, basically, we are observing code changes based on what an engineer is pushing to a branch or locally, and then we take existing historical data from build scans. With this data, then Gradle Enterprise decides to tell us, hey, you know what, I believe that you should be running all these tests because this might be associated with your code change. The other ones are not really relevant to this. So what we have seen with this is that you can get into the point where you only run between 40-44% of your test suite, and that speeds up the developer feedback loop. It's very important to know that with this kind of technique, you are trading the testing comprehensiveness for faster feedback. So it's really about how can you get to an engineer faster feedback when they are iterating on an idea, and not so much how long it takes to deliver a product. The way we use it is by We enable this for your local development, and we enable this for you when you are working pre-merge pull requests. We will never skip tests for you or avoid running tests when you are releasing an artifact. So at least we run all the set of tests when you try to release a new version of your application, library, framework, you name it. So why we decided to go with this? Well, we were looking at the simulations on local and CI builds for a few months. And when we started getting more and more adoption of JUnit platform, which is required under the hood, we found that we could be saving hundreds of days per month. That's cool, right? So that's 30,000 hours of savings in a year. But this really doesn't mean much. It's more about how happy or how comfortable the engineer feels when they are working in their project. Can they get that feedback faster? Like, can we translate this into CI usage and save resources? For sure, but that's not our main goal right now. So these numbers are super good, but still, it's about the developer happiness, developer experience, rather than actual productivity that we can measure. So we rolled it out to all the compatible projects, as I said, almost 3,500 projects, in an incremental way. So we started like dogfooding these, working with beta customers, then start doing some percentages based on some heuristics that we have until we hit the 100%. And the results were basically the same as the simulation. So that was good to see. We did some adjustments for sure, but we were super thrilled that this particular feature allows us to save 88% of the time that we should be probably not spending running tests that are not relevant to the code change. But not everything goes as expected. So the reason why we're talking about this today is because there is an important thing here. Developers might not like trading comprehensiveness of the test suite for speed. So we got a lot of feedback from engineers where they felt like uncomfortable with dropping a pull request and not getting 100% test execution. So this is another cultural change that we had to work on. And we continue to, tell people how it works, showing the data, that there is no data points that this will fail. At least we haven't had any issues with this so far. We also learned that people might not have the proper modeling in their test. They don't have the proper inputs and outputs. So there are dependencies that we didn't know about, and we're starting skipping some tests for them. So they were like freaking out, right? Like, why are you doing this for me? And the other part is there are people that are very strict with the code coverage tooling. They really want to see how much percentage of test coverage they get on every single commit. And these techniques are trading that for speed. So you should be like really open about it and talk to your customers.
Okay, this brings us to remote test execution. And I'm really excited about this one as well. So what is remote test execution? This is when you're going to take your existing test suites and just distribute them across remote agents to execute them faster. So the tests, their class files, their jar, everything that's on the class path is transferred to each agent, and then the existing test is executed. It's going to stream back the logging, stream back the results back to your build in real time. So why would this be an important thing for us, we wondered? Well, we noticed that when we look at all of our builds, we're actually spending 88% of our time just in the testing phase. So this is one reason why things like predictive test selection, as well as remote test execution, are very valuable for us. We want to make this a much smaller number for running this test execution phase. Some other reasons is we wanted to have a consistent experience between the local environment and CI environment for the things we were talking about earlier. We want to make sure we're having better compute resource usage. That way we're not just ramping up our machines saying that, oh, our build needs more memory because we want to parallelize our tests. But instead, we can distribute these tests to other machines that are going to be running them individually. And overall, we want to have this faster feedback. It's in this developer inner loop where we want to have tons and tons of cycling inside of there so that people are running their tests locally. They don't have to wait till they get the results back from CI, and things are just going to move much faster. So what does this really look like on one of our example projects? This is a project that we have. It's Netflix Gradle Lint. It's something that belongs to our team. And we were seeing that before remote test execution, here is one of our example builds where it ran for an hour, and then we got the feedback that a test had failed. So cool. We get to go back to the terminal, go fix the test, figure out what was wrong, push up the changes, and then wait another hour to see if we're ready to actually release this code change. And that's a really uncomfortable place to be in, quite honestly. So once we enabled remote test execution, we saw a wildly different experience there. So here is the same build just a few minutes later when we turned on the rote test execution, and you can see that it ran under 5 minutes. It's running all the exact same tests. It's running all the same number of tests. It's running everything the exact same way, except instead of being on one machine itself, it's distributed to a bunch of different agents and streaming those results back. So this is an incredibly impactful change that we're really happy to be able to benefit from. I will say that we haven't quite rolled this out to everybody at Netflix yet, and there are some potential limitations that you might run into. So for our example, there wasn't any kind of network or security access that was at play in our repository. A lot of our projects, though, they do have integration tests that reach out to services over in the test environment, let's say, and there's network access policies that enable you to run these tests on your local machine where your identity and access is known. It can run on the CI machine. These are allowed items, but on our test distribution agents, it doesn't have that networking set up properly. Another thing is when we are debugging a test, we fall back to local execution, and so that's going to be different than if you're just running your tests normally or if you're running them in CI. So if you're investigating something that only happens in CI, you might need to change some things, and that doesn't come to mind immediately. Another item is that with streaming all of your class paths and your jars up and streaming your results back, if you're, say, working at a coffee shop with a poor connection, you might see some extra latency inside of there, so you might want to turn this off for a little while until you're back somewhere with a faster connection. So currently, we have this as a beta offering, and so for all the tests that are able to run with it right now that don't have networking issues that we need to work on, we have it rolled out to 6.4% of our builds and 16% of all of our repositories. So that is a good, fair chunk of them, and we are working to close our gaps.
So before we get into the learnings, if you start connecting the dots a little bit, when we talk about the project with the Spring Boot and other technologies, and we were able to reduce the time from 10 minutes to 5 minutes overall, once we introduce things like PTS or test distribution, engineers on that particular project now get feedback on a pull request level in a minute and a half. So they went from waiting 12 minutes to just minute and a half. And that was the thing that really motivated us to continue doing this kind of work for engineers. And there are many learnings along the way. So technology, as always, we are learning new things. Doing this work to get tests faster, not only stop there. We were able to enable teams to do CI jobs parallel executions. So think about that you have an actual running database on a AWS or any other cloud resource out there that you need for your test. Once we start moving these into actual containers that will emulate those particular tools, we were able to just enable parallel execution of that and not being competing for the same resources. We didn't allow people to run multiple Jenkins jobs at a time. Then we also saw an uptick of people that started really testing against AWS cloud resources. Before they would set up these resources directly in the AWS console, they will live forever. But once we started doing more and more investment on telling them like, hey, you should be using this library test containers, there are many modules that you can use with this, they went ahead and started looking into local stack and other modules that will allow them to do better integration tests. And even then, start parallelizing that using test distribution and get the results that we saw with the other projects. In addition, we have seen the CI team, the people that own the whole continuous integration experience at Netflix, even talking to people like when you get problems with compute resources, like you don't have enough memory, enough CPU, you misconfigure your build, there are avenues to fix that without getting into the rabbit hole. You can use test distribution, you can speed up the build, and then we can work with you to make sure that you have a better configuration. But in the meantime, we can unblock you to get into a better shape relatively quickly, matter of minutes or hours. And something that we are definitely interested in to look more deeply is how much compute resource we are not using anymore. As we move or potentially move into a ephemeral CI infrastructure, it's definitely clear that we will need less resources to get this thing going. So instead of running a Docker container or a VM for 12 minutes, we can just run it for a minute and a half. So if we translate that into money, most likely will be cost savings for Netflix. And of course, there is social and cultural things. We learned that, we can apply things to small projects or big projects that are independent, but you can go ahead and look into things that are commonalities and then abstract things away from them. Deliver these as plugins, as libraries, things that you can just add into their projects without users to even do a thing. And obviously, we need to get good judgment. we got great feedback that sometimes you shouldn't be rolling out things for people without them even knowing. Should that be opt-in, opt-out? So things that are not really technical, but more about how you approach your customers and how you deliver that change. It's really important too. And make it simple. Be clear about what's changing, when it's changing, what people should expect. Is there an action item for them? People don't like to migrate things, right? They are already working on their business unit. They are, let's say you're an engineer working on the streaming side. You are really looking into how to make that Netflix live experience better. The last thing you want to do is, oh, I need to go and rewrite my tests, right? So we are trying to find ways to speed up things for people without a single interaction from them when it comes to rewriting or changing code. Over-communicate. Make sure that people know that this is happening. There are forums, there are documentation, there are emails, Slack, whatever works for your company. Make sure that people are aware, because when surprises happen, it's not good. And prevent the migration fatigue. Try to be low effort, opt-in or opt-out, or just do things for people. You decide when it's good for them to require changes, what are the things that you really want them to understand and do. And translate it into better error messaging. When things go wrong, try to provide as many context as possible, as much context as possible. Provide actionable items in pull requests with information about where you're changing things for them. Spread the awareness of the new features. This is not only great for your customers, but also for you as an engineer. You want to make sure that what's the value that you're providing to them? Why do we exist, right? If you do things without them knowing, they will take for granted that you're basically sitting behind your desk all day long doing nothing. Beta test the things with your customers. Talk to them. You will benefit most from them. You will uncover scenarios that you didn't even think of before. And communicate expected outcomes at risk of every single thing that you're doing. For example, in the PTS, one of the risks that people had in mind was, oh, you're going to break Netflix because you're going to skip test. And we didn't communicate well where we were running this thing in particular. After we were clear, we learned that people were freaking out because we had poor communication rather than a poor implementation. And measure before and after a feature has been introduced. We have learned that to make a business case, sometimes you really need some sort of way to tell people like, hey, this is how successful should look like, and then know if you really met that condition. Request feedback. Feedback is key. There is many types of feedback. Pretty sure you will get feedback that everything is great, but also listen to people that don't feel comfortable with it. Learn how to digest that feedback and react to it when necessary. So,
all right, this brings us to our last thoughts. So first of all, the items that we've talked about today can be applied to one project. They can be applied to many hundreds of projects all at once. It doesn't necessarily matter there. The scale of this particular solution doesn't matter. These are all workable. We want to make sure that you leave knowing to treat the testing process well. It doesn't have to be slow, doesn't have to be painful. It could be a nice fun time. It's going to give you the confidence to release securely and confidently. We want to make sure that you're investing on the testing experience. This is something where it can keep up to date with the rest of the production code that's out there. We want to make sure that we're enabling fast testing cycles so that we're running in that developer inner loop, staying in a nice flow state of mind, and really just treat your test suites like the production code. So one more time to go over what we were talking about today, these various solutions. We have flaky test detection and being able to visualize what's going on here, having the test retries. We have predictive test selection so that we're running only a subset of the tests, the ones that are going to be most impacted. We have making changes to how you're loading, how you're setting up your tests themselves, how you're interacting with database layers. We have getting feedback from people, communicating with your customers. And overall, this is just leading to a nice time where you're improving the testing in your developer inner loop. So again, my name's Aubrey Chipman. This is Roberto Perez Alcalea. We're from the Netflix Productivity Engineering team and specifically JVM ecosystem. So if you have any questions, I think we have time for a few of them.